Yes, so let's clap for all the candidates who have registered themselves for the Flash Talk. Yes. So, hello everyone. My name is Abhishek Dhondalkar. I'm working in Joe Software. So, a warm welcome to all the GopherCon India 2025 Flash Talks, the candidates. And in a just few minutes, you will hear some ideas, some stories, and some interesting stuff, and all coming from the Gophers. So I want to take a moment to appreciate everyone who have registered themselves for the Flash Talk, and especially those who are on the stage for the first time. Yes. So let's keep the Josh high, loud claps, and open minds. Yeah, and before we start, so I have one request. So those who have listed here up to 5, so please come on the backstage, and thank you. So let's get started. So I would like to invite Raju. So he'll be walking us through an interesting topic with Bini BFT consensus. So let's see, and over to you, Raju. Yes.
Hello. Hi everyone, I'm Raju from NPCI. So today I'll be walking through one of the consensus, Bini BFT, which is a part of LFDT, Linux Foundation Decentralized Trust. So firstly, let's see. Most of you have agreed that GopherCon is happening in Jaipur. That was the reason everyone is over here. That is nothing but an agreement that we have done that we'll be meeting in Jaipur, right? So we can simple terms, we can say it as a consensus happened between us. So we agreed over one Jaipur town and we have accumulated over here. So let me tell you one thing. So what is meant by consensus? So why it's needed? So a person, if you want to make any transaction or if you want to come to any deal, then we need to have an agreement. So that was the reason the consensus comes into the picture. Consensus plays a very important role. It's a backbone for distributed systems to make a single truth to be as an agreement. Okay. So why do we need this? So there will be a chance of missions may fail, delay in the messages, and act malicious. So that's how consensus can able to solve all these things. So in consensus, we have two flavors. One is crash fault tolerance and one is Byzantine fault tolerance. Most have seen Cassandra or else CouchDB or else YugaByDB. Most of the databases may be using some of the consensus. For example, Raft. So nothing but a crash fault tolerance, which has been used under the hood. And there is another flavor called Byzantine fault tolerance, which is very, very needed when you are coping up within the distributed systems, in the blockchain systems basically. So here I'll be having one of the consensus that we have been developing from past 6 months to 1 year. One of our team members were developing it as a part of Linux Foundation Decentralized Trust. Nothing but Bini BFT consensus. So this is a consensus that came into the picture a few months back, that there is a lag and there is a need of a scalability of a consensus as well when you are dealing with. So nothing but, so here if you see the diagram over there, so there is a client and there is a request pool, there is a primary leader, and there is some shards are available over here, if you see that. So whenever a client sends a request, so it will accumulate into the request pool and it will go to the primary leader and it will get sharded. Because of this, we can see there is most of the communication of network latency will get decreased so that we can see more scalable of the systems. Let me show you a simple example. So I have just a POC, so we'll be running out. I'll be starting a 50 node cluster. So basically there will be 50 nodes running. So all 50 nodes are started and running out. Is it visible? Hope it's visible, right? Thank you. So I'm sending some. Okay. So there is some network delay, I think so. So sorry for that. So it's not able to show you that demo. Hope you understand. So we'll meet on that. So there is a, so basically we can discuss more about it. We'll connect over it regarding this consensus. We are being contributing it, and we're asking for the contributant to contribute for this. Yeah, thanks. Thank you for this opportunity.
It was really helpful. Now, I would like to invite Krishnal Patil. So he'll be walking us something interesting regarding cron jobs. So how about you, Krishnal?
Thank you, Abhishek. Hey, I'm here again. Vishwa? Yes. Controversial statement, isn't it? Cron jobs are chaos in disguise. Now, how are they chaotic? Let's know. How many of you are running Go services across multiple instances right now? A quick show of hands. Many people, right? Now, keep your hands up if you are using cron jobs in all those services. Again, many hands. Now, let's imagine a situation. What happens when all of your instances are running the cron job at the same time and all of them are doing some DB operations? Chaotic, right? So let's solve this problem. Prior to that, something about me. My name is Krishnal Patil. I am software engineer at Josh Software. Me and my fellow gophers at Josh do all kinds of innovative stuff, interesting stuff. And currently, I'm working on world's one of the most trusted and largest network security projects. Now, let's imagine a situation where I have a service and I have multiple instances of the same service running in multiple pods. And I have a cron job which sends email to different people. Thanks for subscribing. Thanks for joining us. And what if I have a cron job running across all those three instances and it sends the email thrice? Or maybe the cron job is a banking cron job. It bills you thrice. This is a chaotic. And how to solve it? Let's walk through it. First solution. The solution number one would be related to distributed cron jobs. So the diagram is showing three instances having some cron jobs, doing some operation on the shared DB. Now, if we want to change the implementation, it would be very difficult for the synchronization purpose. But how you could implement the chaotic behavior and like stop it, let's just check. So we introduce something called as a distributed lock. Now, what the distributed lock does is it only allows one process to execute some operation of DB at one time. For example, a cron job. And how you actually implement it is via GoCron v2's distributed lock functionality. Now, what this scheduler is doing, it is trying to acquire a lock on the DB before doing any operation. So even though if you have one instance or 100 instance, only one will execute the cron job. And it is very simple. You just have to insert one line, gocron.with distributed locker, and pass a DB locker. Now the DB locker could be either a Redis-based locker or a simple named lock on your existing DB. Second solution. This solution is related to the electoral mechanism. Let's just say if you do not have a shared DB on the instances, then how would you implement this problem, right? So to solve this, this approach could be used. Now, again, back to the same point, we have multiple pods of the same service running across the system. And these pods report to a etcd key value store in the Kubernetes. We could just implement gocrons v2's with distributed electoral function here, and just pass the electoral mechanism inside it. So what it will do, it will go and check if there are n number of pods running, elect one pod and appoint it as the leader or the prime. And then that pod will always execute the cron job. And it is simple as it's written there. So you could do that. And let's connect. I'm Krishnal, and I'm open to discussions after the talk. Thank you.
Thank you, Krishnal. So, meanwhile, the next speaker is getting ready. We have here Rahul, who have been prepared all the slides, all the animations, all the screens which we are seeing in the front of us. So, big round of applause for Rahul. Yes, the stage is yours.
Hello everyone, I'm Rahul Jadhav. I work as a senior marketing executive at Josh. So I thought if there is any gap while we are presenting the flash talks, if there is some time for setting up the PPT and everything, what I can do is I can go and give my flash talk. Because my PPT is already ready, all the things, all the designs, all the t-shirts, those are my PPT and slides. So the topic of my talk is conference GopherCon through my lens. So all of you guys are from technical background. I was also from a technical background. I have worked as a QA engineer with Accenture. Then I had a role of business analyst for some time and pre-sales plus Scrum Master. Then how did I land up in a marketing job? So I did my MBA, and I always thought I am more inclined towards creative stuff. So that's how I landed up in a creative job. So when it comes to conferences, I was initially very much skeptical whether I'll be able to think in that way. But the technical background really helped me while designing those stuff, the t-shirts or the entire stuff that you can see, all the technical stuff that I had learned before or I had worked upon, it really helped me. And especially when it comes to GopherCon, it's really easy because the logo itself, the Gopher, it is very creative in nature. And as you can see, it gets easier to design anything. You must have seen all the social media posts for the pre-promotion. And even during the event, there are like infinite possibilities that we can do with the mascot. Also for the RubyConf or the other conferences, it's really easy for us when we think in technical way. So overall, my experience was really good. There is also another point that I get to interact with so many people. And yeah, that's something really, I felt really good. So I wanted to share that story with all of you, that there are few people who are from like another background or some another story, but we resonate with you. The overall GopherCon journey has been equally delightful for all of us, not for just me, for my entire team, and it's been a really great experience. So I hope you all enjoyed the GopherCon, all the designs, all the t-shirts and social media posts, and keep supporting us, keep the love going on, spread all the posts, everything on social media, tag us, and yeah, that's it from my side. Thank you.
Thank you so much, Rahul. Yeah, so there is one question for you, all. So have you think, if suppose you have one facility that without redeploying your application, if you have a chance to change your business logic and automatically it will deploy on the production. So seems interesting? Yeah. So we have our another speaker here, Adira. She will be walking us through the live logic WASM. It's related to WebAssembly. Let's see. Yes. How about you, Adira?
Hello everyone. So I'm going to explain how we can update our function. Am I audible? So I'm going to explain like how we can update our live logic or our business logic or our functions without redeploying or without any downtime using WASM. So that's what I'm going to explain. So first, what is the drawback of traditional updates? In traditional way, like we need to redeploy, may it will disturb the user interactions, or if we are a small logic update, maybe it will break our whole application, and the time for a small change, business iterations will be more. And so how we can achieve, like how we can update our frequently changed logics without any downtime using WebAssembly. So first of all, what is WASM? So WASM is basically a fast, portable, a secure way to run our code. It is basically like we will run in a sandbox. It is so that we can run this sandbox like our code packed into sandbox like in a WASM module that we can run in anywhere, like edges or our server or like any edge devices. So we can run. So that is the use of WebAssembly. The main important thing of WebAssembly is that we can update live logic. So that I will explain how it is. And one main important, this is like it is running in a sandbox. So it is completely isolated from our host or our host application or our server. So okay, so how we are achieving this live hot logic swapping? Basically, three components are there. One is our application host. That is our main building block of our application. So our program or our application logic, we will run into our WASM module, and this application host that can manage this WASM module through API or UI. So ultimately that application host, we are not going to redeploy or we are not going to rerun again. Just how we are managing, just through an API, we will just reload this WASM and just update the logic, it will reflect in our host application. And that also we can keep the track of our logic using any storage config, that is the third one. Next, I will show a small demo. So in this, just I created a small function, just a addition function. So what is happening here, I just created a small function. So my server is running in 80. So this server is my host application or server. So this is running in 8080, and just I have a small function. Here I can write any my core business logic, and then what I'm going to do, like I will just, first I will just create my WASM module using my TinyGo and all. So now my WASM module created. And after that in main, I just wrote two API. One is one reload API and my normal, that function that I wrote, add. So in reload application, it is just reloading my core WASM module. So whenever I will change my logic, I need to create that WASM again, and just I need to reload through my API. So in this reload handle, I am just reloading again. So through here I am using API, we can create any UI or anything so. I'm sorry. Okay, so just I reloaded, and after that, if I'm doing, now I think it's A plus B, so it's 8. So same, now I'm going to change my logic, like just I will change that to minus, but I'm not restarting my server, just I will regenerate my WASM once again, and I will reload through that API. So it became, so in this way we can change any business logic without any downtime. So So use cases, mainly plugin systems like in payments, we can do any business rules will always dynamically it will change. So in business rules we can update this frequently we can update, and edge computing, multi-tenant environments and microservice API. That's all from my end.
Yes. Thank you so much, Adira.
Thank you.
So now, many of us might a big fan of Hollywood films, right? So we have seen some of the fantastic characters from the Hollywood, and one of them is Thor, and we have seen a lot of power in him, right? So, as like Thor, we have one tool called Hamdal. So, Vaibhav is here. He'll be walking us through a data orchestration using Hamdal. Yes. So, how about you, Vaibhav?
Hi everyone, good evening all. I am Vaibhav Thomre, working as a SSC in Pattern India from last 3+ years. So today I want to walk through on simplifying data orchestration and job execution using Hamdal. So let's quickly discuss what was the challenges we were facing and how our team is come up with the solution for that. So the challenges we were facing is that today organizations don't store data just in one place. A typical organization may have their customers' data in a Postgres, their analytical data in a Snowflake, their raw files in a S3, and there's some ML modules on the Kubernetes and real streaming data on the Kafka, right? And so on. So to have these all subsystem with us, the main pain point we are facing is that credential chaos. As a data engineer, I need to have all the credentials with me. I need to have API endpoints with me. I need to have API tokens and all other stuffs. And as a data engineer, if I want to take a data from the Postgres, I want to join that data on the Snowflake and train a module on the AWS, then I need to have expertise of all these three systems. And in any case, if any one of the subsystem get failed, then I need to check all the three dashboards and I need to figure out what went wrong. And eventually our data teams are becoming more infrastructure management experts rather than data experts. So the challenges, and this is exactly happens when we are dealing with the multiple subsystems. What if I told you there is a way to make it as simple as ordering a food from your food ordering platform from the single menu list? Yes, there is a way. So Hamdal, we got motivated from this Netflix journey. A big shout out to them as well. And originally Hamdal is a Marvel comics frictional character. So this Hamdal is a job execution platform, and where we have abstracted all the infrastructural and platform related details. We have provided the RESTful operation between your data tools and your systems, and we have reduced the boilerplate code from the client side, and it is already improved operational control on your infrastructure. And as we have only one tool which is managing your all subsystems, we can easily do any audit trail from that. So if you want to run a job on the Hamdal, let's quickly understand what are the core concepts we have. We have cluster. The cluster is execution environment, which is abstracted from your piece of infrastructure. So your local host can be your cluster, your EMR can be the cluster. Any piece of your infrastructure can be act as a cluster. The second one is the command. The command means reusable unit of code. So in our example, so command, we have a predefined tags and plugins are integrated with our Hamdal. So the commands, we referred it as a reusable unit of code. And the jobs is a complete orchestration request which consists of these three input parameters. So this is a dynamic routing workflow. Once we get job request, how we are filtering out and how we are matching our command criteria and cluster criteria. And once that request is valid, then we are performing for the underlying cluster. Yep. This is, as I have spoke earlier, we have RESTful operations supported for that. So this is how we are getting 3 input parameters. Like in our case, the contest, this is exactly the query which you want to run and the other input parameters. And as I spoke earlier, we have UI for it so that you can do all the audit trails on that. Yeah. And we already made this as an open source tool. We are hoping more contribution from the community. You can take screenshot or the photo of this. So that's it from my side. Thanks a lot. Thank you.
Hey everybody, I'm Prashant. I work as a backend engineer at CodeRabbit. CodeRabbit is a AI-powered code review tool, and we are the most installed app on GitHub, and it's free if you have an open source project or if your repository is public. So let's get started. This is the typical software development life cycle, and you can see in which stage most of the defects or bugs are introduced in your product. And as you move right towards production, the more expensive it gets to fix things in terms of costs involved, right? The industry uses this term called shift left. What that basically means is the earlier in the life cycle you find a bug or issue, it's easier and less expensive to fix it. What this translates to is ideally you want your issues to be fixed before your PR gets merged into your repository, right? With that, you don't get to be the hero that fix that production fire, but you'll be that silent knight who cares about your users. Now we know that code reviews are really important, but they have their own bottlenecks that we have to deal with. I'm sure you are going to relate very closely to the illustrations that I have coming here. We have issues with code reviews that stem from poor engineering culture or lack of processes. And then we also have dealt with peers who are sitting on the code reviews that we have requested from them, which is delaying shipping of the product. And then we have the size of code changes that come in. And we hit the limit of what is possible with the human attention span, right? And then we have developers that use their favorite shiny new LLM tools, generating more code than ever before. This is only making the code review problem and bottleneck much worse. And then there's a matter of how far can you trust the code generated by LLMs. Now, CodeRabbit aims to solve most of these problems for you, and this is how we do it. So when you open a PR, CodeRabbit analyzes your code, not at the surface level, but in a deep manner by running static tools, by doing a code graph analysis, by looking at other GitHub issues, your previous comments, and it gives you actionable review comments that you can act and you can apply readily. It can also write unit tests for you. In this specific example, you can see that somebody has made a very minor syntax error, which can only be found when you run the code, but not in compilation. It can also generate sequence diagrams when you open a PR. This is basically assisting humans in figuring out what this code or what this change is doing. And then it can also give you refactoring suggestions, right? In this example, somebody is passing a concrete struct pointer, and it's suggesting that it'll be good to use a Go interface here. And then it also cares about your users. In this example, somebody has written or made a change to the UI, which may not work that well on mobile screens, and it's prompting the developer to fix that. And let's say you change some convention that you are used to in the middle of your development cycle, and it can make a note of the change that you intend to do. For example, here, you're basically suggesting CodeRabbit that we're not going to follow that previous convention. Our convention has changed, and it can take note from there and be mindful of future reviews. And this is an example of a PR that I opened internally at CodeRabbit. It made a comment that was valid for a previous version of Node and which is no longer valid now. It can also learn from the hints that you give it, right? So our customers have had very good results with CodeRabbit. What's the secret sauce behind all of this, right? It's basically context engineering into words. Yep, that's all I had. Go and try CodeRabbit. Thank you.
Yes, thank you, Prashant. So we have our another speaker. He's going to talk about accelerate performance with GPU. So yeah, so Mahesh is here. How about you, Mahesh?
Hello, hello everyone. I am Mahesh Kamble. I am software engineer at Pattern. So my topic is accelerate performance with GPU. So we all know that the GPU is a graphics processing unit which is specially designed for complex calculation. So So why GPU suited for parallel computing? As we all know that the CPU has a few number of cores, but they are super powerful and they are designed for sequential processing. And otherwise, GPUs have multiple number of cores in the count of thousands. So these cores are uh, optimized for performing multiple operation at once. So that's the reason why the GPU is used for the parallel processing. So this is the architecture about GPU and CPU. So as you see, the CPU has fewer number of counts of the cores, which is sequential, which is used for the sequential computing. And GPU, as you see, the GPU has thousands of cores, which are used for the parallel processing. So this is a behind the scene how the program is executing. As you see, the CPU code is executing in sequence wise. If you have 2 by 2 matrix, then you need to traverse each index for the performing a similar application. So if you execute same code on GPU, so you can directly upload all the data on the GPU, and the GPU execute each operation at once. Each core is executing similar application. So it uses the single instruction multiple threads at data uh, uh, single instruction multiple thread pattern. So I will show you one example of bilinear upscale for the image processing. So in that code, I will be scaling up the images. So I will quickly show you the demo. So for the Mac, I have M3 CPU. In that, the GPU is integrated. So I am using Metal library for executing code on the GPU. So I will quickly execute the code and show you the benchmarking of that code. So I am using animal dataset for the scaling up. So for the 50 number of images, so as you can see, the GPU has taken nearly 44 milliseconds, and the CPU has taken nearly 214 milliseconds, which is nearly 5x, GPU is nearly 5x times faster than CPU. If you have similar operation, then you can directly offload that data to the GPU. So the benefits of GPU, it supports massive parallelism. It is faster for the similar type of operation on the large scale of data. So if you are using GPU and CPU at once, so the Go provides Go routines, which is uses the CPU, and if you use multiple Go routines and a particular operation, a particular thing you can upload to the GPU, then it will automatically boost your program, like it will automatically boost your timings. So the areas where GPU is used most, the machine learning and AI, the GPU has separate cores which is specifically optimized for deep learning. That cores are tensor cores. Like you can also use it for scientific simulation like weather forecasting, weather modeling, and like chemical reaction, what will be happen, that type. And also you can use for crypto mining. we need to perform large scale of hashing on the GPU. So it will be helpful for the crypto mining and also data analysis. So thank you. If you want to discuss more about the GPUs, you can connect me on LinkedIn. Thank you.
Yes. Thank you, Mahesh. So now we have someone special here. So when I was at age of 15, I was playing cricket, doing some fun activities, and might be we all are doing the same. But now the speaker, he's at age of 15, and he's the youngest Flash Talk speaker over here. So I'll be inviting him to walk us through his journey with the code. So how about you, Paras?
Good evening, everyone. I am Paras Prajapat. I am 15 years old and studying in 10th class. I am a software engineer by heart and mind. This is my first time coming on stage, and I want to share my journey with you. When I was 13 years old, I wanted to be a software engineer, but I did not know how. My cousin works in IT industry, so he suggested me a roadmap. I followed that roadmap. In starting, I started to learn through mobile applications called SoloLearn and Rapid. After that, I tried to learn multiple languages at once: Java, HTML, CSS, JavaScript, and SQL. Then after 6 months, I realized that I had not learned much useful in this way. Then I found Free Code Camp. Free Code Camp is a free coding boot camp where you can take part in multiple courses. I have done several projects in Free Code Camp and got certified. After that, I found myself better in backend development. So I chose backend development. I had Node.js and Express.js in my backend tech stack. I have built my first project in Node.js and Express.js. Then in October 2024, I started to learn Golang. Now I love Golang because it's easy to understand, simple structure, and its concurrency and fast execution. That's why Golang is my favorite language now. Since then, I have built 3 projects in Golang. Tech Survey. This is built in Golang, JavaScript, HTML, CSS, MySQL. So this is a platform where user can take part in survey and give their opinions. Now my next project is Laboratory. So this is also built in MySQL, this is also built in Golang, JavaScript, Gin, HTML, CSS, and I have used MySQL as well. So this platform helps students to solve their problems using some tools like gravitational force calculator, mean mode median through image calculator, and chemical formula creator, etc. This is my new project. This is also built in Golang with Gym framework, and I have used Perplexity's sonar model in this. So this is a platform where his user can create flashcard, and with the help of that flashcard, user can generate quiz and get feedback from AI. So I would like to tell you the flow of this application. So whenever user creates flashcard, it is stored in database, and thus request by the user is analyzed by the server that if quiz is already generated or not. If quiz is already generated, then the quiz is sent to the user within few milliseconds. This helps in improving user experience and reducing latency. And if quiz is not generated, then the whole new quiz after generating will be sent to user. So this is my open source project, and if you like, you can contribute to it too. In future, I want to be an entrepreneur and solve problems that are being faced by people in their daily life. In the last moment, I want to tell, keep learning, keep growing, and keep enjoying your journey. Thank you.
Thank you so much, Paras. It's really motivational and inspirable. Yes. So next one we have Divya here. So she will be walking through getting started with open source with Gopher. Yes. Over to you, Divya.
Hello, guys. So can we have hands? How many of you have contributed to open source projects? Oh, a lot of them. And how many of you want to contribute, but somehow you're not able to get there? Okay. So this talk is specially for you, and others can also take some. Generally, when I was in college, which is not very far because I graduated 2 months ago. So when I was in college, I was like, I'll do open source. I'll crack Google Summer of Code and everything. But that didn't work out. But hey, apparently, right now, I am a maintainer of an open source framework. So I somehow got somewhere, not actually reached the milestone that I set for myself, but kudos to me anyways. So yeah, when you're wanting to contribute to open source, what I used to generally do is go and look at some fancy issues and be like, oh, this is not my expertise. I don't think I would be able to contribute to this project. I used to go to these very big start repos and everything. But what you can do is actually start small. You can start with your college websites or your internal projects that can be open source because they are not proprietary. You can do it in your company itself. And that is what we did in our company itself, because our framework was not something proprietary. So we made it open source. So if you go and check out Gopher, that is actually an open source framework that gives you a microservice development environment. So HTTP, gRPC, WebSockets, cron jobs, we have handled everything, and we give you inbuilt instrumentation in that. So if you're interested to actually come and contribute, you can also check out Gopher. You can also, there are a lot of sites, as I was talking to Gautam backstage, he told me that there are a lot of sites that actually scrape those good first issues for you, and you can actually work on those issues. But a very minute detail that most of the contributors always forget is actually reading through the repository's code of conduct, contributing.md files, and they do not adhere to these things. So whenever you come to a repo, I would suggest that you first read through these files. And other than that, you can also go and join their Discord discussions, their meetups, and you can actually have design discussions that, oh, I'm actually interested in this project. I'm actually interested in having this feature. Do you mind that if I contribute this? And do you want to approach this problem in this way? And sure. And a lot of times it also happens that you cannot continue with that thing, you have some time constraints. So you can always direct it to the maintainer that, oh, I'm sorry, I would not be, could you actually take this forward? And generally, the other people do come in, you can collaborate with them. And yeah, that's, I think, what we at Gopher also do. We have a lot of issues. You can come in, you can ping me there. I am by the name Cool Wednesday there. So you can come and tag me in those issues that you're interested in contributing to. And yeah, we can collaborate, and there can be some good PRs merged. All the first PRs that get merged in the repo, we'll be shipping free t-shirts to them. So yeah, I hope you guys contribute to the open source framework that we have built, and that's it. Thank you.
Thank you, Divya. So we have Vishaka now here. She'll be talking about static analysis of nil in Go. Yes, the stage is yours, Vishaka.
Yeah. So, hello everyone. Um, yeah. Myself Vishakha Sainani, and I started as a software engineer at Josh. And it's been around 8 months since I've started working with Go. So, well, let's start with my most and least favorite thing in Go, which actually is this. Yes, the panic that we get at runtime. Yes, the one thing that actually shows up when you think your code is just fine, right? So let's first see an example where when exactly we get this panic. So as you can see, I am trying to access an uninitialized variable to a custom type. And this code compiles fine, right? But it would give me a panic at runtime. So we wouldn't like this, would we, right? So we need something to avoid this. Well, what we can do, one thing is we can try and write clean code. But let's accept it, we all are humans and we tend to make errors. So I was exploring and I actually came across the Go's nilness analyzer. The nilness is actually a static analyzer by the official Golang, and how it works is, it works inside a function. So basically it checks each assignment with a tautological condition, and it would output one of the three states, which would be a nil, a non-nil, or an unknown. Why unknown? Because it tries to avoid the false positive cases. So let's see an example of how it works. So again, I'm trying to do the same thing, trying to access an uninitialized variable, basically value. And I am this time actually checking it with the Go's nilness package. And I would get a warning at the compile time itself that it would give me a nil dereference. So let's see another example. So as we saw, this is pretty simple, right? Let's see another example. So herein, I have a function which returns nil. We can see it simply returns nil, and I'm trying to print the value it sends using another variable. But when I try to run this code, it wouldn't give me a warning at the compile time. But why? Well, because there is a catch. So as we saw earlier, that the nilness package actually works inside a function. So it's intra-procedural, not inter-procedural. So that's why it wouldn't track across different function calls. And also, it does not have function contracts. So it's not possible for the nilness package to infer if a function would send nil or may not send nil, right? So, well, we wouldn't like this again, right? So I was exploring more, and I came across a blog by Uber, wherein they mentioned that they were using the Go's nilness package, and they found this issue, and actually in production they were facing this, and they came up with their own package, which is nilaway. So Uber's nilaway is actually built using a 2SAT problem. So it is interprocedural, unlike Argo's nilness. It actually works across the function, and it uses contracts like non-null and nullable, and it also overcomes the bugs that actually nilness misses. So let's quickly see how it works. It just, again, we have the same example. from the earlier part. Here again, I'm trying to access the value from the function that returns nil. And this time, the Uber's package will actually give me an error, or basically a warning at compile time that there's a potential nil panic detected here. So that's it. And well, still, even Uber's nil away cannot, let's say, cannot warn you that your code may break at runtime and will give you a panic at runtime. Because, well, let's say you are trying to process a data from an external system. So you would know that it would be nil, right? So even I am exploring towards this. And if you are interested, let's connect. Thank you.
Thank you, Vishaka. So there is one request to all of you. So those who have their name in between 10 to 15, they are requested to come to backstage. And now I'm requesting Suhan to take over at the stage. He'll be walking us through his experience on problem solving at scale. Yes, Suhan, over to you.
Uh, so uh, recently in our project we were facing a problem. So I will be sharing how we solved it. For the presentation, as it's 4 minutes long, I have simplified the problem and kept the code itself. So the problem was we had a service which, example, we had to detect if the email was like a spam or not. So we had a list of emails. It was in millions, which we knew that these are the spam emails. So we had to, given an email, check if it was in the list or not. So in a simple word, we will simply be selecting from the database. But as we had millions of records, we could not do it. So we needed some fast solution. So what we did, hash map. Just joking, guys. No, it was not hash map. It will take all the CPU in it. So what we did, it was Bloom filters, a simple like probabilistic data structure, uh, which is lightweight and is used for checking if the element is not present in it. So before getting into it, let me introduce myself. I am Suhan Bhandari, working as a software engineer at Joe Software. Currently, I am working on projects including networking and security in Golang. So what is a Bloom filter? So Bloom filter is basically a data structure created from maths. Yeah. So in a hash map, we can check a key if it's present or not. But on a Bloom filter, it can say that if the element is not in there. Suppose I have a list of emails, spam emails, and I want to check if Suhan Bhandari at the Joe Software is present or not. So it can definitely say that it's not present. But if it does not say no, then it may or may not be present in the list. So how it works? First, we take our array. Each item is hashed, and then the numerical representation is stored in an array. And then whenever a new email comes in, we check if the bytes match. If any of the byte does not match, we can conclude that the email is not present. But if matches, we cannot conclude that it is present, because if we know one element has the same hash whenever we use a hash function, but it may happen that two emails can generate same hash. So we cannot be certain that it's present. Now the examples where like it's used, especially in banning systems, if we have a list of IPs, we can easily check if the IP is like malicious IP or not. This is used at DNS level, because on systems where memory is low, The Bloom filters only takes KB of memory because it's just a numerical representation than having the actual IPs on the edge itself. There are different cases. Just don't use Bloom filters like hash maps. They are their own. Now let's see how we can do it in Go. So we simply create, we are using the library I listed there. We call the new function. We then add the string. We can use the test function. And then this function is used to store our Bloom filter in the memory itself. The key takeaways were, as we discussed, you can connect me on LinkedIn, GitHub. My name is Suhan Bhandari. Thanks.
Thank you, Suhan. Walking us through escape analysis and memory management. So I'm inviting Krishnan Kumar. So yeah.
Okay, so hello everyone, myself Krishnan Kumar Fatehpuria, and today I am going to talk about escape analysis and memory management. So today we will be knowing that what's escape analysis and why it matters. So let's talk about. So first talk what's escape analysis. So escape analysis is a compile time process in which the compiler decides that which variables are going to use a stack or which variable are going to use a heap memory. So why it's matter? Because stack allocations are faster and they are reclaimed inside a function only. Instead of heap allocations, use garbage collectors to reclaim these memories. So I have a code snippet also here. So in this code snippet, we have in both the functions, we have declared like a array, a slice of array, and in both the functions we are returning a variables. So in above functions, as we are returning variable by value only. So this functions variable is declaring in a functions and destroying in a function only. So this is declaring as a stack variables. But instead of this, in another functions, as we are returning it as a reference, so it's using a heap memory. So for this, we need garbage collectors to remove or to claim these variables. So first we need to know what's garbage collections. We already have talked about the garbage collectors. So in this slide, I will mostly covering. So how does the garbage collector works? So garbage collector basically goes built-in system which runs concurrently with our program. So as it has very low latencies. So how does it works? So like initially it's like there should be some algorithm to work a garbage collector. There should be some thing will be behind it. So first, how does it recognize that which variable should be garbage and which variable should be removed from our memory? So first, initially, it all the variables will be as a white nodes, and it take a root node and start from there exploring. So first, it explore all the children of their root nodes and mark them as a gray node. After that, it explore the children of that gray nodes and mark them as a gray node, and the above gray nodes mark them as a black nodes. So how does it recognize? So it recognizes black nodes as a live nodes, like which are like using in a programs, and gray nodes like which are reached but not yet scanned properly. So like because we didn't reach the children of these gray nodes, and the remaining white nodes, the collector known them as a garbage. So it removed these white variables, and this algorithms happen concurrently. So like it has a very low latency, and like it's concurrently running with our Go program. So developer doesn't know to know about this also. And so summary like why the escape analysis matter, because to know that which variables are going to use a stack or which variables are going to use a heap memory, like stack memories are faster, and GC overload will be less in that case, and it reduces the post time also. So the latency will be low in that case. I have a quick demo also for that, like how can we recognize that which variables are going to use a escape or which variables will be removed from the code. So here I have a code like which you have seen in a code snippet. So in these two functions, to know which variables are going to escape, we have a command in Golang. So one second. Okay. So we have a command go build -gc flex. So with that command, we can see that which variables are going to escape. So for these variables, we need garbage collector to remove. So here, there it's clearly written that age escape to heat. So for these variables, we need garbage collectors to remove them. And how the GC works alongside. So here I have also written a heap function in which the variables are going to use heap memory and how the garbage collector reclaiming these memories. So one second, here I run this program. Okay. I think time is less. So here we can clearly see that garbage collector reclaimed the memory. Before running garbage collector, the memory used was 2490 and after that it was 1530 only. So that's it. Thank you.
Sure. Yeah.
Hello, welcome. I am Chakshu Jain, Senior Associate Blockchain Engineer at NPCI, and this is Go Maps Revolution with Swiss tables. The recent improvement in the Go Maps using Swiss tables is no less than a revolution. Today, I will be talking about Go Maps implementation using old and new approach. So in Go 1.23, maps are implemented using buckets of size 8. When we have to insert a key, we take hash of it and determines which bucket it belongs to. Then we sequentially check each of its slots and sequentially. And if the bucket is full, we create another bucket called overflow bucket and links it to the original bucket using pointers. This approach is called chaining with pointers. The problem with this approach is that overflow buckets get memory allocation far from its original keys. This makes it CPU cache inefficient and slower lookups and insertion. So let's see how Go 1.24 addresses this problem using switch tables. Switch tables are a form of open addressing. So in Go 1.24, maps are a directory of multiple switch tables. So there is a single backing array of size 1024 and divided into logical groups of 8 slots. There is also a metadata array called control word, which tells the state of the corresponding slot in the group, whether it is empty, deleted, or in use. Now when we have to insert a key, we take hash of it using a hash function and determines which group it belongs to. Yes. And now instead of doing sequential comparison, we do parallel probing using SIMD instructions supported by SIMD hardware. And if the group is full, we probe into the next group. So these two improvements, parallel comparisons and implementation without chaining, makes this approach very cache friendly and significantly faster. Now let's see what's the real world impact. So in micro benchmarking, map operations are up to 60% faster. Also there is a Datadogs case study where they did rigorous benchmarking on a large map having entries around 3.5 million entries. And they observed an impressive 70% memory reduction. So like what's next? So there are more improvements in the pipeline. Few of them are extending SIMD support for more architectures. Currently, Go 1.24 supports AMD 64. Also, group size can be increased to 16 slots, which means 16 parallel comparisons, and therefore less average number of probing. And then there are some research around elastic hashing, which could also contribute to further improvement in the performance of Go maps. Thank you.
Thank you, Chakshu. So, our another speaker is Mayuresh here. So, he's talking about playwright in Go. Yeah. So, over to you, Mayuresh.
Hey, hi guys. I'm Mayuresh Pawar. I have been working in Pattern from last 1 year, and in total, I have 4 years of experience in Go, Ruby on Rails, AWS, React. Also, I'm a data enthusiast. So today, I'm going to talk about like Playwright in Go, how we can automate browser using Playwright in Golang. So to start with, what is Playwright? Uh, you must have heard about browser automation. Like Playwright is an cross-browser automation tool which works in which works for like you need to automate something from browser, like you need to take a screenshot, you need to intercept requests, or you need a DOM to analyze, then you can use Playwright. Playwright is a cross-platform, like it works on Windows, Mac OS, and everything. The special features of Playwright are it works in headless and headed mode. So what is headless mode is headless mode have the feature is whatever running you can't see, it's running under the hood. And next is like the key features of Playwright. So you must have used browser automations, the various type of browser automations like Selenium, Puppeteer, but Playwright has a distinguishable feature which is it retries and wait for the DOM to load or the request to get fully loaded on the web page. Then it starts their automation. Then it can also emulate the device. Like if you want to test something which runs on mobile, then you can actually emulate that particular part on Playwright. Then this is just a short code of a Go and Playwright. Like it is just launching a Playwright instance, then creating a page, then it's going to a particular website, and then it taking a screenshot and saving it locally. So I'll just quickly show you a demo of that, like how it works. So this is a very basic code of Go, which has creating browser and all. I'll try it running. So as you can see, I am running this in a headed mode right now, so everyone can see what is going on. So it's going to a particular website, and it's going, when the page is loaded, it will get a screenshot of that and save that page to local. As you can see, this is the screenshot we have right now. So that's how fast the Playwright is. So coming to use cases of that, like where we can use Playwright. So as you can see, web scraping, if you need to scrape anything from a static website, dynamic website, you can use Playwright. Then end-to-end testing, also in CI/CD automations. I'll just quickly give you an example, like in CI/CD automation, where you can use it. Suppose you can add it as a smoke testing tool. Like suppose you will have a post-deployment smoke test CI step in your CI. Then what it will do is, it will capture a screenshot after post-deployment, and it will compare that particular screenshot with the previous screenshot. And if there are major changes over there, then it will notify you, hey guy, there is a lot of changes, please have a look. So likewise, we can use the Playwright. Then this is the comparison of it. I won't be telling everything about this, but as we know, Go is really fast, very concurrent, and easy to deploy. And Playwright is also really fast. So if Playwright and Go comes in the picture, this is really, really fast. That's all for it. So these are my social handles. Please connect if you need. And thank you.
Yes. Thank you, Mayuresh. So our next speaker is Atmaram. He's currently working with Sedin since last 13 years, and he will be talking about stopping stateful task in distributed setup. So yes, over to you, Atmaram.
Hello everyone. Thank you for giving me opportunity to talk over here. I'm going to start with my slides. Stopping stateful task in a distributed setup. Before that, about me, my name is Atmaram Naik. I'm working at Sedin Technologies since last 3 years. I'm lead developer and SME of a tool called as a SetStart. And I'm available on Twitter with this handle. You can scan QR code. You can connect me over LinkedIn as well. Before the actual PPTs, I'll run the demo. So this is our tool. You can see it has 2 tests. It is a test automation tool. It has 2 tests. I'm going to run those tests. Hopefully network permits. You saw that message popped up, run created. Now I'm going to stop the test. You could see there is a gray mark over here. The test was stopped in middle. It also generated video and all. This is very small feature as it seems, right? But there is a challenge that we encountered while building this. This is what is happening behind the scenes. Front end is sending a call to API server to stop the test. Okay. Now, when we run a test, this is what is actually happening. Front end sends a request to run the test. It is sent on a run queue. And then run queue has a multiple test. It gets broken down into multiple other messages. A worker doing a job of orchestration as well over here breaks down that message into multiple sub-messages of each test. You could imagine it can run hundreds or thousands of test cases as well. So it will get distributed on those hundreds or thousands of test cases. Now there is queue for each browser. You saw I was choosing Chrome. So you could choose other browsers as well, and there is a queue for each browser. And then that queue gets loaded with those test messages. And then there are workers which are running there in their own world. They are not connected anywhere. They are running the test. And I sent a stop signal. So what could be the challenges? We don't know in which worker container the test is running, right? Server is not directly connected to the worker. Worker is stateful, so stopping it in middle is something like stopping and probing into the running code. So let's introduce a signal queue. What happens when you put a stop? API server sends a message on a specific topic of a signal. Each test has its own signal queue, and worker, when it starts the test, starts listening to the signal queue as well. And we have instrumented worker. You saw each test is nothing but sequence of steps. So at the each step, at the end of each step, we check if there is a message on a queue, we stop. And that's it. That's how you can simply implement stopping a stateful task in a distributed manner. That was my talk. I hope this architecture challenge and solution fascinates you. If you need more info, you can connect me.
Yes, thank you, Atmaram. It was really very helpful. The next speaker we have is going to talk about GraphQL with Go. So here is Aditya. He'll be walking us through with the GraphQL. Over to you, Aditya. Thank you.
Good evening, everyone. My name is Aditya Padekar, and I'm from Joe Software. I'll be presenting GraphQL with Go. So I've been working with Go for last 8 months now, and when I was first assigned my first project at Joe Software, it was a project that utilized GraphQL with Go. Now, I never used GraphQL, never built any apps with GraphQL, so it was a new experience for me. And my first question was, why are we moving away from REST? Because I always built my application using REST API. So let's start with what is GraphQL. GraphQL is, in simple words, a query language that allows allows front end to query data that it needs from the backend. Now, why GraphQL? Now, there are a few strong points about GraphQL. Like, it has single endpoint. You can query each and every kind of data from just one endpoint. Also, it has strong typing. I absolutely love types. It tells you everything that you need to know about a function call or a query call. Now, it also lets you fetch exactly the exact amount of data that you need and nothing extra. Yeah. So how is the GraphQL implemented in Go? So first, you have to write a schema in .graphql files. So the schema usually looks like this. So you define a type, you define an input type, you define mutations and queries. Mutations are used to make changes in the database, and queries are used to retrieve data from the database. Now, okay, we defined the schema, but now what do we do? Now we have a tool called GQLGen. It allows you to generate the necessary Go language code that will be used by the GraphQL as a handler. This is how the generated code looks like. It has two parts. One being the types, and second being the resolvers. So now we can look at the type. Look at it closely. We have two types, two kinds of definitions. Typing. One is normal typing like strings, and the other one is pointer to a type. So basically pointer to a string and pointer to a boolean. So these we'll get back to them later. Just they are important to us. And these are the resolvers. These actually work as handlers for a server. Now, okay, we got the GraphQL setup done, and we are ready to work with it. Now comes the real part. When we start building applications, when we start running our server, we run into most common problem, nil dereferencing problem. Now, as the types had field that can be nil, like the pointer to a string, pointer to a boolean. Now, what if our input type consists of such types? So in these cases, if we don't handle this nil check, our program is going to panic, and we are going to run into runtime panics. So what do we do to handle this? So there are many ways to handle it. One of them being you make sure that you validate and map all the things that you need at the resolver level, and then pass it to the service layer. Or you can make sure use a helper function that will convert the nil pointers, to the zero values to equivalent to the types that are used in Go. And make sure we try to make sure that service layer is only focused on business logic and not any kind of validation or verification of the input. Now, we also need to make sure that the errors written by GraphQL should be structured, because the errors let the front end or the user know what went wrong. But now, as these kind of errors are, many different kinds of errors can occur because of pointers, we need to make sure that we are returning good error message to the front end. Now, yeah, I know. Last way. So with GraphQL, there are many problems when like n+1 problems. When we want to query some kind of data, and it has nested objects in it. Now let's say this is an attendee table, attendee query. But we also need to fetch all the tickets bought by that attendee. So we can write code something like fetch the attendees, and then fetch all the tickets for all the attendees. Now we run into n+1 problem. As GraphQL lets you choose what is to be fetched from the front end, but there is it is not similar at back end. When you give some kind of query, you don't know what kind of query the front end has requested. So these are some cases where you might need to handle the N+1 problems. Thank you.
Thank you, Aditya. So our next speaker is Gayatri Suresh, and she will be walking us through from roots to resilience, Strangler peak patterns in action. Stage is yours, Gayatri.
Hello, hello. Am I audible? Okay. How many of you guys are familiar with what a strangler fig tree looks like? Please raise your hands if anyone is aware. Okay. So for those who are not aware of it, strangler fig tree has very thin branches which wraps around a main host tree in a spiral pattern. The spiraling does not happen at once. Okay, this happens slowly and gradually until one day where the whole tree is completely wrapped. At log n radius, we followed a similar fashion to modernize our API architecture. Hello everyone, happy evening. This is Gayatri Suresh, software engineer from log n radius INC. So why is this architectural pattern so important to us? Well, it starts from migrating a legacy system. So the problem of migrating a legacy system into a modern system is that it is very difficult to remove the modules. Also, backwards compatibility is very limited. And, well, yes, big bang rewrites can cause collage in production environment. So why risk it? Strangler fig pattern is a modern architectural migration pattern where slowly new modern components are implemented on top of legacy patterns without affecting the existent system. So this change happens slowly until the legacy system can peacefully retire. So talking about it from an engineering perspective, we can say that to have a legacy system implemented, we can utilize a strangler fig pattern. So what we do is, initially we can carve out the independent boundaries of a legacy system, then we can identify routing patterns using which we can direct the traffic. Once that's done, we can follow either dual write or shadow traffic to sync both modern and legacy systems. When all these are done, towards the end, we can slowly migrate the traffic to the modern systems once the legacy system is no longer needed, as mentioned before. Of course, strangler fig pattern is not all unicorns and ponies. It's a little computation intensive because we have to do dual write. Other than that, migration is a long process, so it takes a lot of time. Well, it takes a lot of discipline and monitoring to keep these things in track. You know, the benefit of this pattern is very beautiful. Okay, so this pattern gives zero downtime, which is very critical for enterprise level customers. Other than that, risk isolation becomes very easy because the modern components are built on top of the legacy components. So we can easily isolate the issue and we can roll back to the previous checkpoint. Other than that, we can clearly observe the modern and legacy architecture's performance live. It also supports parallel development, so it's a win-win for devs. So let us mirror it with our strangler fig pattern. The way strangler fig wraps around the parent tree, we mirrored it with a dual write mechanism. And this bit by bit branching is pointed towards our slow traffic redirection to our modern systems. So for we, as a CIM providers, how does this make an impact? With this migration, we were able to maintain 100% uptime, which is very critical for customers. Also, our response time increased for up to more than 50%, ensuring smooth customer performance. Well, using this, we were also able to deprecate our critical APIs like a cakewalk. So what did this strangler fig pattern made us realize is that instead of doing such big bang migration in a sudden and complicated way, we can achieve it slowly, safely, gradually, and in a resilient way. Martin Fowler, the great personality who popularized this architecture, rightly said, incremental changes are way better than risky big bang rewrites. Well, this incremental migration has taught us that incremental migration for a legacy system can also result in longevity. That's all from my end. Thank you.
Thank you so much, Gayatri. It was really interesting and helpful. Yeah. So we have another speaker calling you Debashish, which is going to walk us through build tags. How about you? Stage is yours, Debashish.
Hey guys, good evening. This is Debashish Nandi, and I have been using Go since last 5 years, ever since my college days. So one of my previous companies, my manager suddenly comes one day and says, the tools that we have been developing in Golang, which are specific to Windows, now we have to migrate it for other platforms like Linux and Mac OS, because we are planning to shift to different platforms so we could expand our audience. Now, this task was given to me. I was new to this, and I had a lot of inexperience with writing tools and tool chains which are going to be used in production. And I have to develop it for Linux and macOS systems as well. Well, there was a problem when I was trying to compile it for them. A lot of libraries which we have used in our modules were very OS specific. So in Windows, we were utilizing DLL files for throwing some system calls, notifications, and all. Now, this made me think, like, does Go have any better way for handling all these things? Well, it does. But since I didn't know at that time, I used some random things which were not so good to use in production code. So these are the two things I tried. Both of them are wrong, so please don't take them as a reference. So first, we have an environment variable giving the details of the which environment you are running it on. Based on the environment, I'm deciding if I have to run this function, which is a notification function very specific for Linux, or if I have to run some other function, which is very specific to macOS. Or I would use my legacy Windows function if that is not defined. That was bad, because now I'm depending on an environment variable. And I would not expect my customers to be putting up this variable in their own client device. That was not an option. So we came back to some other method. This is using the runtime.goOS. We have goOS flag in Golang, right? So this is defined in our compile time itself. Let's say you're compiling your code in a Linux environment. Your goOS is set up as a constant variable as Linux. Now, the switch map inside it, it will decide which part of the code you want to execute, which function you want to execute, based on the goOS variable. Now, this is also bad, because now if you want to compile it to in some other platform like Windows, you will have the code. But now you also have a lot of dead code that you are not using. You have a function, notify in Windows. You have a function, notify in Linux. You have a function, notify in Mac OS. Now, uh, when you have compiled your binary, you have other two as well, other two functions as well, which you are not using at all. Now, you are compiling that code into your binary. So these are some of the problems that we face when I came up with this kind of solution. But let me list out those problems as well. First, the code that I'm writing became messy. I'm having a lot of functions which are platform dependent, and they are being compiled into my binary, right? But now this is in a small scale. This is just one function that I'm talking about. What about 100 functions? What about read operations? What about the write operations? For every OS, it has a different way of doing it. Now OS is going to change. Like we are going to compile for Windows today. We are compiling for Linux tomorrow. Now we don't want to zip this bad code into it, but it is going in. Now the next issue is with testing. Now you have written some test functions which are very specific for Linux, and you have written some functions which are specific for Windows. When you run the test, it will depend on your OS that which test will pass and which test will fail. And these are all false positives. Probably the both tests are passing, but because your platform, the platform which you are running it is not the one platform the test you are running for, that's why it is failing. You don't want this to happen at all. And there is another issue of accidental misuse. Let's say for the same notification service, I am trying to call the Darwin function because we are humans, we could make mistakes. Now, if I made this act, then what would happen is my tool will fail with a panic, something that I would not expect as well. So for that, we have one thing in Golang which could use, which is known as build tags. Now, what are build tags? They are compiler directives. So they tell the compiler what files to use, what code to use when you're building the binary. Now, you're telling the compiler specifically these rules by specifying in two ways. One is file name suffix, another one is explicit tags. These are also called as build constraints. These are in the form of comment on top of a Go file. You are not required to do the second part, but the first part is very important. Oh, let me continue then. Yeah, we're complete. Yeah. So with this, what happens is now you're separating the whole logic into different, in all the different files. Now, only in one file, I have all the services for notifying return for Darwin, for Linux, for Windows. Now, this handles the code readability part. Now, you're able to create smaller binaries as well because you're telling the compiler which files to use for your compilation time. And once this is done, it is a compile time enforcement. So, so basically, you will not be determining in runtime which OS you are going to use, for which OS you have to use which function. That is not there at all. And the best thing is it is idiomatic. So basically, Go uses it everywhere. So it is something that we need to use as well, because that's the standard way of handling cross-platform files. Now, this all depends on your GoOS and GoArch environment variables. So how do they actually work? Now, so for the file name rules, we have this particular suffix that we need to include, which is underscore, then the OS type, which is Linux or Windows. If it is for Linux, you have to put underscore Linux. And if it is for Windows, underscore Windows. And you have to put the same functions inside both of them. Now, you do not need to mention the build constraints, but it is something that you should do as a best practice. So it starts off as a comment, and this line should be added on the top of your package file. You have go :build, and then the OS target that you want to mention. Now, there is also custom tags that we can also define, but now your Go compiler cannot smartly handle it because custom tags is not something that Go identifies. That is a name that you give. So you have to mention it in runtime which files to use, giving this tags flag, which is mentioned in the bottom line. So let's go through an example. So in the end, we have in the last section, you see that there is a common API, which is going to call your notification service. Now, notification service is written in both Mac OS and Linux. In the Mac OS part, we are calling the OSA script, which is actually a script that we use in Apple for doing all the system call messages. And on the Linux, we have notify send, which is actually responsible for throwing the notification on the pane. Now, if you're building this thing on Mac OS, then it will only use the bottom notify.go file and the notify Darwin file. It will not use the Linux file for compilation. But when you're compiling it for Linux, you will be using the notify.go file below and the notify linux.go, which is going to create a smaller binary for you, which is specific to Linux. So in the end, we could conclude with use build tags, have no dead code, build smaller binaries. Thank you.
Thank you so much, Debashish. So this was the last flash talk for today. Thank you so much for your patience. Thank you so much for hearing all the flash talk speakers, and looking forward to tonight's party. With that, thank you so much all. Thank you.